Hi, yo, welcome back to the channel, everyone. This video is going to discuss hydrostatic pressure. So before we get started, I'm gonna just give you fair warning. Go get a graphing calculator, go get a couple pads of paper, make sure you have an architectural ruler. We're gonna be diving into the world of engineering and physics. We're gonna be working on some pretty complex formulas, and I'm kidding, we're not doing that. This is gonna be a simplified version of what hydrostatic pressure is, how to find it in a home, how to mitigate that hydrostatic pressure, whether you're doing it for primary residence, investment properties, whatever. And it's gonna be a lot of fun, I promise. It's not gonna be boring, all right? Make sure before we get started, for real, find that subscribe button, hit the bell for notifications so you get future videos in the worlds of home building and real estate, the entrepreneurial version of everything. If you do like this video, on the way out, do me a big favor. Let me know by hitting that thumbs up, all right? Without further ado, we're gonna do a little whiteboard work, we're gonna do a little on the computer work, and at the end of this whole video, you're gonna be an expert in hydrostatic pressure, or at least you'll know what it is. Okay, so what is hydrostatic pressure? Basically, it's a function of fluid mechanics. And like I was joking earlier, we're not gonna get into the engineering and the chemistry behind hydrostatic pressure. We're gonna keep this simple and more in line with just home construction and, more importantly, real estate. You can use this information really as you guys are moving forward. Ironically, I've actually had a lot of people in the last few weeks, maybe because we're getting a lot of extra moisture this month and the last month, or there's just more people out kind of like jumping into the investment world and they're looking at flipping properties, they're looking at investment properties. All be said, they are going into homes, they're going into basements, and they're seeing things and they're questioning what's happening. They're seeing movements in floor, they're seeing cracks in foundation walls, and they're asking me, what the heck is going on with this house? Is it worth it? Is there structural issues? Is this a no-go situation like we've discussed in previous videos? Blah, 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 right? So really what I keep telling them is, as I'm looking at videos, I'm looking at photographs, I've looked at a couple properties with some people, and I've said this over and over, what's going on here is hydrostatic pressure. And they look at me, deer in headlights, and we break it down to a point where they understand what's happening to the home and what to do to mitigate it. Okay, so all the chemistry and engineering beside, we are going to talk simply about the actual mechanism that's causing the signs you're seeing in the home. Okay, so this pressure that we're talking about is actually excess moisture building up underground in the soil itself. That's caused from rainwater and snowmelt, right? Percolating into the ground. And when there's an excess amount of water in the soil, you start building up pressure against the outside of the structure of the foundation wall. So it starts pushing against this wall because it's looking for a way to move. Again, that moisture is coming from not only above ground from rain and water, it can also be groundwater itself, especially in areas of high water tables where you actually have an area where maybe a basement shouldn't have been built, or you've got a stem wall that's too deep based on a soils report itself, which is why you only build based on what the soils engineer is telling you to do and not go against the grain, which I've seen in many, many homes over the years. Big problems in homes even built in the last 10 to 15 years, where somehow they're getting away from what the soils engineer has recommended as far as what type of structure to build and how deep to go with their stem wall and their footing, okay? So in this case, on our simple whiteboard explanation, this is our stem wall, this is our footing right here at the base, and we're talking about this pressure, that's excess water that's going into the ground, and there's no way to mitigate that water, all right? Especially in older homes, you're gonna see where there's no sign of mitigation work, i.e. drain systems, that will get water to move away from the foundation. And we'll discuss here in a few minutes all the different ways to mitigate it that you can do. And then other more in-depth, I would call them, ways to deal with this excess moisture buildup that are not going to be super, super expensive, okay? So again, when people are walking homes or you're looking at, a structure and what you're seeing is you're seeing either signs of moisture built up on the inside of this wall here, okay, where you're going to have moisture buildup. You could have efflorescence, which is basically content of salt and other aggregates moving from the outside to the inside and actually pushing that aggregate through the wall, where you see that salty or white look on the inside of an old wall, brick walls, concrete walls, you can see it. That's a sign of excess moisture getting through the structure itself and actually causing issues. On the minor side of this hydrostatic pressure, those issues could be basement flooding, all right, where water has found its way in on the path of least resistance through expansion joints, which we have to have in these walls, right, to help with movement. They can find a way in here. If they've actually, the water itself and the static pressure has pushed enough where it's actually created its own cracks, that water continues to move in and down walls, you start having another area where you can have water finding its way around the footing and up underneath the slab here itself, which will flood the basement. But even more particularly, you can start seeing signs of movement on the slab where you see the slab step up. You know, you have those expansion joints that they're almost stair-stepping, or you have cracks within the actual slab around and away from those expansion joints. Those are all signs of hydrostatic pressure. And again, the mechanism behind it is just excess water in the ground that's created this pressure with soil that's expanding and swelling and pushing against this wall. Now, you can understand once this has happened for a while, if I'm talking about pushing a wall in, what ends up happening is you can start having forces so great that that wall can start buckling and cracking, all right? That force behind it is pushing so hard, it's literally as if you're shoving somebody from their torso and they bend. That is a sign of, and a problem, because you're gonna start having structural issues with the home. So if you have a combination of forces pushing and cracking this wall, pushing it in, and you have water coming up around the footing, up under the slab, you're gonna see signs of heave on the slab. But if you can see what's happening with that wall, if that wall is to buckle here, you're gonna have other structural components of the home start to move as well, where you can have forces push up on the framing members. You could have sag, depending on what happens at what connection point of the structure, where you can actually have the floor drop. But you're gonna start seeing signs above grade that will point you in the direction of hydrostatic pressure as well. Cracking around headers of windows, cracking around headers of doors. We'll look at these pictures in a minute of other signs of hydrostatic pressure where I talk about horizontal cracking, step cracking, all the things that I've kind of pointed out to people to look for as they're walking these properties and trying to understand what's happening. All right, so now all the scary stuff aside with basement flooding and structural movement and failure, we're gonna start talking about ways to mitigate and what are the good ways versus the okay ways versus the bad ways, all right? First thing, we wanna make sure we never have foliage, i.e. trees, right? Forgive my artistry here. Trees up against the home. We don't wanna have any foliage that's too close to the home. I like to tell homeowners to keep all of that stuff that needs water a good 10 feet from the structure itself, okay? So trees away from the home, bushes away from the home. A lot of cases, if you can do xeriscaping and walkways around the home and move that sod, move that grass away from the home, you're gonna keep water from wanting to build up against this house and come down, all right? So foliage is a big, big component of trying to mitigate water very simply. Another component is obviously make sure when we're building homes, we have even gutter systems, all right? I see homes built in all locations, and because of the style and what they're trying to do, they're trying to mitigate water without an overhang, without a gutter system. We want that overhang to take water off the roof and literally run it away from the structure, right? We're trying to protect the wall itself. If you don't have the eave, you're having water literally travel down the side of the house where it's not being pushed away. We're gonna have water issues within the wall itself, which is moisture buildup, rot, but we're also gonna continue to allow that water to drop down right next to the foundation and again, percolate on down, building up excess water, okay? So eaves and gutters, right? We wanna have an eave and then we have that gutter system right here that's gonna take water out and away from the home, okay? Wow, that's a really bad arrow. That's where we want the water to go. Third component is we want to have grade. We don't want to have any sloping or negative slope that's going to continue back towards our property itself. We want grade to go that way. So we want to have gravity take water from that structure and run it out and away from the home. That's just a simple ideology of building up soil so it's higher here than it is here. So we're just sloping the soil at the home away. New construction, every builder should be doing this. We have code that dictates where it should be running and what that percentage slope is. If you think about a drop of 6 inches in the first 10 feet, that's what we're looking for as far as positive grade away from the home. That's step 3 as far as mitigating water. Now, what a lot of homes are still not getting, especially newer homes, what's surprising is they're not getting the correct water mitigation system below ground, i.e. a perimeter drain. I've done videos in the past on what a perimeter drain is. If you haven't seen those, go back and check those out in the How to Build series. What I'm seeing is a lot of remediation work from homes that are struggling with this hydrostatic pressure, and companies are coming in, and what they're doing, let's clean this up real quick. What they're doing is they're building in an interior drain tile system or an interior drain system. And what that is basically they come into your basement and they'll cut away sections of your slab up against the foundation wall, and they'll put in perforated pipe, and they're going to have that wrapped and waterproofed. They're going to have gravel within that trench itself, and what that drain does is it grabs water, so the drain will be sitting right here. They're cutting this slab away, and what they'll do, and the good ones, and I'll go that in a minute, will actually mitigate the water on the interior of the wall. What that does is it's grabbing water that's finding its way up and under the footing, and it's keeping it from coming into the basement, okay? That drain is picking it up, and it takes it out and around the footing to one or several sump pits that have a pump. And then that pump takes water from whatever the pit is, and it's got a pipe that pushes water up and then out and away from the home, all right? The problem with these systems, hence why you're still gonna see some sort of pressure, is yes, we're grabbing some of the water that's created, this buildup, this excess buildup of water, as it builds up around the footing, and we're taking it out of the home. But we haven't grabbed any of the water that's up here that's pushing against the structure, right? It's only picking up water that's already found its way up and around the footing into the interior structure of the home, okay? So albeit this is better than nothing, this is not the proper way to mitigate water below grade. Okay, so before we move into the computer, I'm going to show you exactly what needs to happen with a system built correctly. Step 1, this entire wall, and this is code and is inspected in most municipalities across this country, this wall needs a waterproof, a minimum base waterproofing system, okay? I don't like just rolling on waterproofing. You're keeping water from building up into the actual concrete itself. But this needs to have a dimpled membrane, all right? We want water to percolate up against the home and run it down to an exterior drain system over here, all right? So our exterior drain, combined with a waterproof system that's percolating water up against with a membrane system and literally driving the water down around the footing and into an exterior drain where none of the water is being allowed to come up and around the footing, and none of the water is being allowed to get into the actual structure below grade because it's waterproofed on the exterior of this foundation stem wall, okay? Stay with me. That water, as it moves down into this drain, then is doing the same thing the interior drain system is. It's taking water out and around, and there's now 2 ways to deal with where to put the water. If you're on a sloped lot, we can actually have the water daylight. So this drain system just takes it on around, down using gravity out to the pit, which is below, it's lower, down the hill than the drain itself, and it just literally pops out of the ground as a drain, and water runs out into a retention pond, retention ditch, whatever it is we got a culvert of some way, and that neighborhood is actually collecting all that water and moving it out and away from the entire neighborhood. That's just civil engineering, simply put. We want water to go away from our homes. We want water to go away from our buildings. Water is a bad thing in so many ways, especially structurally, okay? This is the ideal way to mitigate water below grade. You need to have perimeter drains, not interior drains, perimeter exterior drains, okay? Now, the argument with a lot of builders, even on new homes, because they're still putting in brand new homes, they're still getting an interior drain system. The argument is, well, we don't have a way to daylight the water. We're building homes on flat lots, in flat neighborhoods, and yeah, we're mitigating work around streets and curbs and sidewalks, but we can't put the water in daylight anywhere because it's on a flat lot. So what they do is they run it all the way into a mechanical drain, a mechanical pump from the drain system itself, and pump it up from the interior and out. But again, like I explained, the water coming up and around the footing is already getting into the home. The argument there is pretty weak because you could do the same mechanical pump system on the exterior. If you can't daylight it, you can still run it to a pit and a pump on the exterior of your home, bringing that water back up to grade and pumping it away. And now several pits would be better than even one at ideal locations around the perimeter of your foundation. Same idea is held in place. It gets a little bit more difficult as far as running power to these pumps and the location aesthetically, but the idea is still the same, okay? So as far as saying I can't daylight a system, that's pretty weak because what you're trying to do is just avoid having to put in any more power and mechanical systems on the exterior, especially with aesthetics. I get it, but if you want to avoid this altogether, this is the way to do it, okay? Gutters, eaves, grade correctly per code, and then an exterior perimeter drain. All right, so all that explained, that's what hydrostatic pressure is. That's how you mitigate it. And now we're gonna go look at how to determine what's happening with the home and am I seeing hydrostatic pressure? And now that I know if that's what it is, I know how to mitigate it, and you can move forward or walk away if you're looking for investment property, or if it's your own home, you know now what to ask for and how to do it.
Okay, so picture one here. Those are some really, really, really ugly looking cracks. You can see the horizontal nature of those cracks as it's pushing through the plaster on the interior of that foundation wall. That's a bad sign. This house was built before 1930, okay? It's had some interior structural work done throughout the cellar itself. This is kind of like an oversized crawl space, basically, which is like a lot of the homes that were built around this time. But this is a sign of hydrostatic pressure. This is what is happening when that excessive water builds up on the outside of that wall, expands soil, puts pressure against the home, and pushes in, like I was showing you on the whiteboard. And basically what's happening is it's pushing in towards that middle of the wall, and it's buckling the wall, all right? This house, like I said, it's built before 1930, so it's had zero mitigation work done when it was built, obviously. There's no drain system at all, but it still does not have any drain system, and this is in an area that has excessive water issues. It's got negative slope towards the house. It's got foliage up against the house. The gutters are actually broken, and they were clogged as well. Section of gutter was removed. There are no downspouts on the house. So you can see all the combinations we talked about on the whiteboard are all leading towards shoving a bunch of water up against the foundation wall, and that's what you're having. This is actually causing pretty severe structural damage to the home, and it's caused heaving within the house itself. We have wood girders, which is the interior middle beam of the home that's been pushed up, which is causing the floor joists to move, crack, subfloor cracking, all the way up to the roof itself. So this house has a lot of severe problems. All right, here is a CMU wall. So this is a concrete masonry unit wall. That's what the blocks are that you're seeing in this photo, and that's not an uncommon thing even to do still these days. But there was a certain amount of time in a certain era where this was a pretty popular way to build and an inexpensive way to build foundation walls and footings too in some levels, but mostly walls. You can see the step cracking that's happening here, and I'll get my mouse on this, but it's basically cracking all along these joints of those CMU units, all right? That's redundant, CMU units. But the step cracking is also a sign of hydrostatic pressure. You can even see where it's actually alleviated itself down towards the base of this wall, and there's a long horizontal line. Same deal. You've got a lot of pressure built up on the outside of this wall, pushing against it and causing this wall to start to fail. It just cannot hold any more water back, and it's starting to break down with that hydrostatic pressure. This is the very beginning of what's called kind of exploratory work to see how much water is built up down here, right? So starting to chisel away the slab to see what excess moisture has gotten up underneath the footing itself. I was actually asked to come in on a similar house like this to figure out if an interior drain system was worth doing as opposed to doing nothing at all. And because of cost, a lot of times that exterior drain system after the fact, that remediation work becomes a lot more expensive, because if you can imagine, we've got to dig all the way down to the footing on the exterior of the home, all the way around the home to put that system in. So hence why you have interior drain systems being offered up, is because, like I said, it's better than nothing. It's better than doing nothing at all, and it does alleviate some of the pressure against these walls. But you still have to do work in here, not just sealing it up, but also shoring up these walls. Sometimes we have strapping and helical piers that will pull these walls back upright, along with a drain system itself to kind of fix this work. But again, long story short, this house had a lot of issues with water mitigation, water management work that was not happening. And needed to happen. So along with these interior drain systems, if you're going to do them, I don't advise this is the best way to do it, but it's better than nothing. You got to mitigate the rest of the water itself on the exterior of the home. Moving water away from the house is so key, and there's so many really, really, really easy easy items to take care of that you can alleviate. It's a lot less expensive than starting to get into these drain systems. If you don't do them in conjunction with the drain system, it's worthless, meaning adding gutters, fixing downspouts, adding downspouts, moving foliage away from the house, grading the home properly. All that has to happen in order to get this to stop pushing, okay? Let's take another look at another picture here. All right, this is another picture I actually stole off the internet. You can see the credited source down here during an inspection, and holy crap, look at the amount of pressure pushed against that wall. These blocks have actually simply forced their way inside the vertical direction of the rest of the CMU wall. Again, this is a concrete masonry unit wall. So these units here are all built together and mortared in place to create the stem wall. This has completely failed, and you can imagine, so you can see floor joists sitting on the top of these blocks here on top of this wall. What do you think is going to happen once these things kick out completely? This floor is going to drop. Really bad situation. This is to the point of this house is going to be on the ground in a matter of who knows when, all right? This is a serious, it's very severe structural issues. This is one of those where you have to come in and actually start building in temporary beam systems and footings in place to repair this entire wall. So again, I've seen similar situations to this, maybe not even this severe, but I have seen these units kick out completely like this. This is, again, a sign of hydrostatic pressure. It's a lot of pressure being pushed into the wall itself to the point where it couldn't take any more, and it actually failed to this point. Any further than this course kicks out, like I said, these floor joists will collapse, and everything sitting on top of it will start to fall too. It's not going to be one of those dramatic like demolition videos you see on YouTube or on the news where they blow up buildings, but the house will start dropping very quickly. And again, you can imagine the type of work that has to happen if that was to continue to be allowed to fail. What's going to happen to the rest of that home? You guys can kind of figure that out. Let's take a look at one more picture. I'm having a hard time zooming in on this thing, but you guys can kind of see. Let's see if I can do it a little bit better. Okay, so if we zoom in on this photo, and I'm not sure why the thumbnail actually pulled up the smaller version, but it is what it is. So as I zoom in, the graining gets a little bit worse, but you can see the idea here. This is, again, an 8-inch thick stem wall on a home that actually is not that old. I think it was about 8 or 9 years old. So pretty modern construction, and same thing happening. This is actually in a home that has an interior drain system, okay? So you can see this is about halfway up the stem wall. The water, like I showed you on the whiteboard, the water that's going down the outside of the wall, up and around the footing, is hitting that drain system and being mitigated. In this house in particular, their sump pump was running pretty heavily at least once a day. These homeowners had me come out and take a look at it because the gentleman was concerned with how often the pump was actually running and how much water was coming out of it every day. They were not in a floodplain per se, but they were pretty close to a creek. They were certainly elevated above the creek. Civil work had been done in the neighborhood. There was a retention area. The foundations and the stem walls were built up at a certain elevation per soils engineers reports, but they were all done with interior drain systems because their claim was they had no way to mitigate the water and daylight it from the exterior if they were going to do an exterior drain system. Well, you can see what happens. Water's still going to create expansion and pressure halfway up this wall, and it started cracking. And this wasn't the only house it was happening to. There was other homes in the area that were having, this was a more severe case, but they were having small horizontal cracking start to form within the stem wall itself. Again, this is a sign of what you're trying to look for if you think there's something going on. This doesn't mean the house is going to collapse, but it means you have hydrostatic pressure, you have water management issues, and you have to address them, okay? So this is a good place to start when you start seeing these things, especially you guys that are out there looking to invest in property, you're looking to flip homes, and you're walking homes, looking at key components of, things that are going to be a no-go or no-go situation. And if this is something you see, this horizontal cracking, and you're seeing even weeping and staining on the concrete, other water clues, other flooding issues you might be able to key on as far as below grade water intrusion, these are all signs of hydrostatic pressure.
Okay, so hopefully that explains hydrostatic pressure on a level you can see when you're walking homes. If you're in your own house, you start seeing these issues, you know what you're sort of starting to look for. Now, for everybody that's out there hustling on the real estate side and you're walking homes, and I know a lot of you guys have contacted me, showing me pictures, so forth. So once you find these issues, once you see these issues, don't always assume you know exactly what's happening. This is a good starting point and a good pinpoint of what to understand what's happening with the home. Get a structural engineer out there to walk the property. It'll cost you a few $100 for them to assess what's really happening, write their synopsis of it, and even give you an explanation of what can be done to mediate that issue. And from there, if you need to move forward and you want to start doing work on the home, that engineer can actually draw plans that can actually be handed to a contractor to submit for an estimate. And you can figure out how much that work's going to cost you, what's it going to set you back, how long is it going to take, and is it worth it? So hopefully that helps. If you got any other questions, like I said, drop them in the comments below. Check out the other videos. I've even got structural assessment videos on here. I appreciate you guys checking in. And until next time, you guys, keep building.